Hey guys, we'll switch to this screen a little bit early again, because I think I have most of the things I need in place. Can everybody see and hear me okay? Let me know. There's always a little bit of a delay. Hey there, Bart Kreeft. And Aurel 5x5 Quindor says Richard Campbell. Yes, I can hear you. I can hear you. Well, that's a good basis for a live stream if people can at least hear me. Yes, audio and video are fine. Cool. Yes, we can see and hear you. Okay, thanks for that. Welcome to this stream tonight. We're gonna start easy because, you know, have to give people some time to get in here. And, well, we started a few minutes early again, so... Do you have a new camera? It's like sharper than before, or better light. Nothing has changed. So maybe it's YouTube on your side. I do stream in 1440p. So it's a bit sharper than the 1080p you see in a lot of other channels. But it's still the same camera, same lens, same lighting. I actually have profiles set up for all of that, so literally nothing changed. Quindor looks crisp. Hey, I'll take it. Cool. So I don't want to talk about what we're going to do today yet. I guess the thumbnail told you a little bit. But how are you guys doing? I mean, this is my Friday evening. I like spending it with you guys. You guys have any plans for your Friday evening? Or is this your Friday evening plan? Let me know. Do you have different LEDs on the QuinLED in the back? Or did I not watch closely enough recently? Again, nothing changed. Maybe something that changes that I set the LEDs in over there and over there, no, whatever, to color cycle a little bit. But other than that, they're still the same. There's nothing really changed that. Oh wait, my music is still like really loud. Sorry about that. There we go. It's 12 noon here and I'm working. Wish it was evening. I get that. But all is sharper. Perhaps YouTube changed something in their codecs or something. Maybe. I'm literally doing the same. I'm streaming 1440p using OBS, using my Blackmagic Decklink Quad HDMI recorder, all set to 4K, but I stream in 1440p. Yeah, I did get like a haircut, and I did a fairly proper shave. Maybe that's what you're seeing. Oh, cool! You're using SpaceX to catch the stream. That's nice. Yeah, I have a decent cable connection. We're streaming 16 megabits up, and I have a total of 40, so generally that works out. Oh, Emo Bart says, today my plans are nothing special, but tomorrow we're going to shake up Amsterdam, Rotterdam, Utrecht, Eindhoven, Nijmegen, and Groningen. Wow, that's like, you're doing like a world trip in the Netherlands. Okay. Everything what? I'm really happy everything looks sharper and stuff, but I don't think anything changed. You've got 400 down and 11 up? Oh, on Starlink. I was going to say, that's weird, but okay. On Starlink, I guess that's decent. On the Quad 4 behind you, how is it terminated on the top? Terminated on the top? What do you mean? It just has the cables? I guess I can lift it a little bit. Like that? Is that what you're asking? It has a little cable clip there. And that holds the cables in place. And it's stuck to the wall with double-sided sticky tape. Because we all know I love double-sided sticky tape. Oh, it's an event protest that's going to happen tomorrow. Ah, I didn't know about that. Well, I heard about it, I think, but didn't know when it was. Looks around? Mm-hmm. I don't know. Oh, no, yeah, it's the same as it always. That I literally haven't touched. I mean, I touch OBS sometimes to record actual videos, which I do with different settings, but other than that, no. Nope, all the same. But hey, better quality, I'll take it, even if I didn't do anything. Sure, that's fine. Oh, Johnny Bergdahl is here. Good evening, ladies and gentlemen. Oh, Andy's here, one of my moderators. Cool. Hey, Quinn, missed me? We haven't talked on a lot of live streams from other people this week. Maybe we can do that during this weekend. Who knows? Oh, I actually won't be home tomorrow. So I won't be... No, not tomorrow, but maybe another time. Yeah, I bet, Emil. Cool. What do you guys all think of the last video of the house sign number? I think it turned out great, and I really put some effort into the effects and stuff like that. But let me. What do you guys think? Is it worth the effort to put in those pieces with the music and all the zooming and stuff like that, or is it just like, nah, skip that crap? Oh, Kenny says, just received my Dig Uno yesterday from Dr. Z's. Can't wait for the LEDs from Aliexpress to play with. Yeah, I can imagine that. Whoa! Streams are starting ahead of time lately. I try to... That's my secret is that the stream time is 15 past 9. Because I would always struggle to be ready at 9, but then I'm mostly ready at 5 past 9. So then I'm early. The house number is awesome. Oh, nice. It was really great. Cool colors and nicely done. Okay, thank you. Yes. Okay, well, that's the things I need to hear so that I put more effort into those things. It's not like the video did any better, but it's okay. It's all planned out. Hey, if I can plan around my own quirks, you know. Now, we were going to do stuff with switches today, but I'm just wondering, where did I put them again? I think we're going to have to do some searching around in a minute, because I actually don't remember. Oh, I know where they are. Wait, they're pretty close by. There we go. Oh. I think so. Yes. See, they couldn't be far. Okay, that's for later. Okay, so it's 15 over. We have 64 people watching. That's decent. So today we're going to be taking at some AC switches, and if you watch Quinbox, you've seen these. Let me take this one. So these are generic wall switches from Aliexpress, and I'll have them listed in the description. I think they're already there. Don't need screws or this, whatever this is. And well, these are just wall switches which you can screw to your wall. But I was thinking, well, a switch is a switch, isn't it? So maybe we can like abuse it to, I don't know, here is a An-Penta prototype, which has 3 dedicated switch inputs, because those are input only pins on the ESP32. And maybe we could hook up some switches and then see if that works. And then maybe we can hook up like a 10-meter cable and see if that works. and we can see what we can do with that in ESP Home, like if we do a short press or we do a long press. And the stretch goal of today is these have LEDs, and I'd like to know, will they work? Will they not work? How much power do they need? Is that only AC? Should we open it up and see how that's built in, and maybe there's a resistor there we can replace? So yeah, we're going to do the... My nose is itchy. We're going to do the simple test first to see if we can actually... yeah. Oh, it's blowing out the microphone. These are really... They don't need a lot of force. They need some force, but they're definitely physical switches here. I also have some with the touch switches, but maybe this one is a good one to try on. And I guess the first thing we should do is figure out how it works. And we're going to do that with a multimeter. So let's put this to continuity mode, or beeping mode as I call it. Okay. So we have several screws here. Okay. And then we have the holes for the screws, and I guess some or none should be connected right now. Yeah, no, I don't think anything is connected right now. So it's everything's disconnected, right? Yeah, okay, well, this is not disconnected, but that's the same hole. Okay, so now what happens if I push it in here? Yeah, okay. And then... Oh. See, now this is interesting. This works. Oh, huh? Oh, okay. This switch works differently than I thought. I thought it was a toggle switch, or a momentary switch, but it clearly isn't, because right now you can see I have them in these two holes. They're not connected, and if I press the button, now they're connected, and if I press it again, now it's not connected again. Okay, well that kind of... Why would you make a switch that's not momentary that looks like this? That sucks. Huh. Well, we can still use it. Yeah, it's a latching button, yeah. Okay, well, that's unexpected. I really thought this would be a momentary switch, especially because of, you know, the design and how it looks. Right? But we can still play with it. I mean, yeah. So, let's get a little... Let's hook up the board first. And I need these plugs because I'm going to hook it up to my bench power supply so I don't give it too much power. I can use this one. So let me make a little power cable for that. Live stream with no surprises. Yeah. Generally that doesn't happen. I mean, if I wanted no surprises, I'd prepare better, and then we'd have a video where everything goes right. But, I mean, where's the fun in that? Okay, let me screw these in. I'm still not expecting magic smoke today, Philip. Sorry about that. Oh, okay. Yeah, I don't have much knowledge about building switches and stuff like that. Okay, plus, minus, and right here off the screen there is my my bench power supply. Okay, it's powering up. So let's set that to VSET 24 volt. And let's do half an amp, I guess. No, yeah, no, let's do 250 milliamps at 24 volts. That should be fine. Yeah, on. Okay, seems to work. Now I believe this one has ESP Home on there, but I am not sure. And we'll have to write a little config to do the button sensing basically, and then I'll have to magically make that appear on the screen. Let's do that right now. Let me prepare my browser a little bit. Let's see here. Browser. Home Assistant. Okay. That should work, I think. Let's go to Supervisor, ESP Home. And this is the test An-Penta. And I believe I already have the button configuration in there. Yes. So in the configuration file, I have the binary sensors for GPIO 34, 35, and 39. And those are these three terminals. Now on the board, and now let me power it off. On the board, it has pull-up resistors and a debouncing network of my own design, which pulls high the pin. So all these pins should have 3.3 volts. We can check that. Let's see. So we have the ground terminal. So this is ground, and these should all have 3.3 volts. Yep. Yep. Nope. Oh, okay, yes. Okay, so all these pins are pulled high. Oh yeah, Philip bought one of these Raiden PSUs he's building right now, so that is definitely the sound, that's true. So yeah, we just have a binary sensor. And did I do anything else with that? We don't really need all of this. We don't need this either. Let me take this out because I might want to reuse that. I've been testing with different displays and stuff like that, but okay, yeah, that's fine. Don't need this either. I thought I connected an action to the button presses, but I don't see it. Anyway, let's save this and hit install and see if we can do it wirelessly, because then it would be online. Let's give it a second to boot. Of my own design, eh, Mr. Fancy Pants? Yeah? Oh, it's a circuit I'm testing. Oh, wait, Johnny did make a change in my circuit when I shared it on the Discord server. That's true. But this one, I don't believe this one has the change already. The next version will have that change incorporated. But in the end, we determined it was like 0.01 volt of a difference, I believe. Okay, so it's uploading. So this is the right ESP that I thought it was. Cool. You can get, you guys, oh wait, no, I wasn't showing the right screen. Sorry about that. Okay. Right. So now we should be able to, like we did last time. Hey, Phil is here. Welcome. If I now short one of these pins to ground. Oh yeah, okay. It's changing an LED channel, but I don't remember where I put that in the configuration. Let me take that out because I don't want to see all those messages. No. No. Right, on press. Let's take on press out. We can play with that later. But this is basically how you can automate something outside of Home Assistant in ESP Home. So right now it was set to, if the button or that pin was pressed basically, it would perform an action, and those actions would also be reflected in Home Assistant, but they would be performed locally on the device. But currently we don't really want that. We just wanted to show that the pin is closed and open. Yes, ESP Home is OTA, yes. So it compiles this on your Home Assistant server, or in my case, my Home Assistant VM. It's running Dockers inside of the VM, and then it uploads that over IP. It's perfect. So first off, we just want a sort of status display if the button is pressed or not. That's kind of what we want to know. Okay, it says it's booted, so let's try a button. Okay, yeah, so now when I'm holding it, it says state is off, and now its state is on. You could see that as reversed, but you can invert that if you want to. So we now have a status display, and if we use the other pin, yeah, that's pin 35, and then we use this pin. Yeah, and that's pin 34. Okay, so that works. Do we start with a short cable, or do we just immediately hook up the long cable? I'm kind of thinking of just hooking up the long cable and see what happens. But if anyone says short cable first, I'll do it. I don't think anyone will. Short cable first, or go ham with the long cable immediately? I'm waiting. What? Oh no, Andy said short. Okay, Andy. Okay. So what we're gonna do is we're gonna connect red to, I guess we'll use this pin. Let me make sure that's open. Never say never when I'm here, says Andy. Yeah, I guess that's true. Okay, so let's put red in here, because as I just explained, the pins are pulled high. And then let me get a ground pin here. Yeah, that should be open. Oh, lots of people here. Jack Allen says, hello. Hello there. So we just determined that for this one... Oh, what? Why is my nose so itchy? Maybe it's these switches. That we're going to use this one. So I guess, what does it say? LB1 and LB. Okay, well, fine. I don't care. We're going to put the wire in and then screw it closed. This is not the right screwdriver for the job. Okay, and then this one. Right. Okay, I had power turned off to the board, by the way. So now we have it connected to, well, on here it's LB1 and LB. Not sure you can see that, but that's okay. Much cleaner on stream with short cable. Yeah, well, we're going to try the long cable too. So now let's power it on. Okay, nothing's happening. That's good, I guess. Let's wait for the logs to reappear. That's not even a screwdriver. No, it's one of those, you know, one of those old school you put into your electrical socket and then you ground it and then it has a little light inside. So it's a really an electrician's screwdriver. Now I don't do anything AC, but you know. Okay, I see that it's sending its uptime sensor again. So in theory, if I now press this button, nothing happens. If I press the other button, there. Now it's off. Now it's on. Now it's off. Now it's on. Live stream done. Yeah. No, okay, well, I expected this to work, you know. But we do see that the LED, if there's an actual LED here, which I would expect, well, it doesn't do anything. So, yeah. Thrown in the darkest part of the tool block, okay. No smoke, no smoke. No, I can even, you know, click it really fast. And, well, it's pretty stable, so that's good. Yeah, okay, well. Okay, so that part works fine. That's, okay, well, I kind of expected that part to work fine. So let's turn that off. So that means, at least for short cables, you can actually just use any generic wall switch and wire it up as plus and minus, or in this case, pooled high and ground. And default state is then high, and then you pull it to ground, which overrules the resistor that's pulling it high. Yeah, and the debouncer is working fine too, because there's no software debouncing in ESP Home right now. You can do that, so there's no debouncing configured in ESP Home right now. I believe you can do that, and we'll experiment later with button presses and times and stuff. But yeah, so why is this cable not coming out? Okay, I need this. Give me, okay, that one's came out. Ah, okay, well there's a new invite, Jack Allen, but maybe my old videos still have an old invite. But I'm pretty sure Andy of Philip is going to drop an invite into the chat any second now. Did I screw up this screw terminal? Should I go the other way? No, this is definitely tight. Huh. It doesn't want to come out. Okay, there, got it. Not sure why that was stuck. So these are the latching screw terminal. Yeah, you can't see that from up far, but there's actually a little latch that moves up. Anyway, let me get a decent screwdriver. Oh wait, we can use my electric power screwdriver on this one. Okay, so short wire done. Let's test. Well, this is about 10 meters of wire. It's AWG 18, so 0.75 millimeters squared, which is, you know, it's an average size, I'd say. Oh, what we didn't test for the LED is if we turned the wires around. That would have been interesting. But, okay. Did I beat Andy? Yeah, we'll open it up later on. Don't worry. Because I'm really interested in the LED if we can make that work. That'd be cool. Status LED on off. Oh. Have you tested any electric screwdrivers? Oops, asked too soon. Yes, I have. I use the Xiaomi Wo stick, and for lighter screw jobs, and a lot of stuff is around the bench, I actually really like it. So yeah, that's this thing. There we go. Okay, so now we have a giant bunch of cable, and to make it even worse, I'm just gonna do it like this. And, okay. Let's turn that on. I have to wait for it to boot again, which gives me time to work on the drink of the day. It's a Coke. Coke non-special zero. Because we don't have any special in the fridge right now. Yeah, that's right, Adam. It's not super strong, but it's very useful. Invite from a different person, but same result. Could it be ad blocker? That's odd. I mean, thousands of people have used that invite, so... Coke Zero, simply the best. Well, Coke non-zero is the best, but then I got diabetic. so now it's the best. Okay. Let's see if we have logging already. Yes, we do. So, I believe it was this one. Yeah. State on. Okay. State off. Special zero is like vanilla or cherry or something like that. Off, on, off, on, off, on. I mean, yeah. Okay. That seems to work. If everything works this easily, I'm not sure what we're gonna do. But there's no LED. So let's reverse the wires. And see if that changes anything with the LED. Okay, that wasn't really a great screw job, but you know. Let's just wrap it up. Why are we even testing? Right? Okay. Let's get that ESP online again. Timeout. Timeout for what? Yeah, my Wo stick has an LED. Of course. Doesn't yours? I mean, hey, there we go. If I screw it, it turns on. Okay, we have contact again, so let's okay, well, the button works just as well, which, well, it's just a connection or not a connection, so that was to be expected. But the LED that's supposedly in here, no change. Yeah, it's definitely not momentary press, which I had hoped. But we have some other switches which we can test if those are momentary press or not. My Wo stick does not have an LED. Give me an affiliate link. They're in the a few previous live streams. I don't think it's on this one. Sorry. And otherwise, I can do it in the Discord server later on. Yeah, normally they're built for the LED to work with 240 volt. That's definitely true, MSX Droid and Stefan. No, don't. We're not going to be putting 230 volts on it. Currently, there is 3.3 volts on it, pulled high, and then it's connected to ground. Yeah. if it's switched. Okay. Isn't the LED powered with one of the other screws? I don't know. Well, we can try it. Oh, wait. So let's open these up. And I guess I can put it in here. But then how do I know if that's going to switch? No, we have to beep it out first. Yeah, we'll do a tear down in a minute if we can get it open. But let's do a test first. Okay. Wait, let me change the screen. There we go. So, okay. Nope. 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 Yeah, okay. Okay, this is connected. It's not connected to this. It's not connected to this. Okay. And if I press the other button, this is still connected. Not connected. Not connected. Okay. Press this one. Okay, this one's now turned off, and if I now it's turned on. Okay. Okay, and this one's turned on too, and that's this button. Yeah, okay. So it's 2 buttons and 4 terminals. So, I mean, that kind of makes sense. So I don't think there's a common terminal or an LED terminal in that sense. Okay, well, we already tested this works. Do we want to test more? Do we want to test... I want to do one more test. Let's do one more test, and that is 2 buttons. Because it has 2 buttons, let's see if we can use it as a 2-button device. Okay, and let's take the short wire again. I do have a second ground here. I have to open it up first. Oh. Okay, I think it's open already. Come on. There we go. And the next button pin. Now I'm using this An-Penta, and it does have the debouncing network, but you can also use a Dig-Uno or Dig-Quad. You'll have to use DuPont cables, but I mean, that should still work fine. And those can also have pull-ups and pull-downs and software pull-ups and pull-downs with an ESP32 on there. So in theory, you could also do this for WLED and stuff like that. But those do expect a momentary press, so this switch might not be ideal for that. Okay, let's turn it on and wait for it to come back. I'm not 100% sure from head what I used on these. I think it was also one UF. But I posted it a little while back in the PCB design talk on the Discord. So we can check that later. Or maybe Johnny still knows. Well, it does depend if you have a 1-gang or 2-gang switch and if it's meant for looping or not. And these all aren't. So we can now switch pin 34, or we can switch pin 35. Yeah. That seems to be working just fine. I'm reading chat. Hold on a second. If there's two L's, then there are two neutrals on AC. Okay. Yeah, so on the back here it says LA1 and LA and LB1 and LB. So I think these are just two through connections basically. We can try another switch. Let's do that before we move on to wrecking one. So let's turn this off. Okay. Let's put this over here. Let's see. What kind of switch do we have here? Oh, this is an... Okay, so this is definitely a not a momentary press switch, because you actually physically move the buttons. Let me see if I have a momentary, because that would actually be cool. Oh, do we want to try one of these? These are the glass type with the capacitive touch buttons. Oh, that's interesting. I wonder if that would work, because we're not putting the kind of power on there they might be expecting. Let's try it with the short cable. And this one has L. Oh, let's see here. Yeah, L, L1, L2, and L3. Okay. So it only has live. Yeah, live in and then 3 live outs. But then is there a relay in there? How does that work? Wait, I can't get this open. Okay. Oh, it's just really stuck. So is this what you were talking about, Andy? Jesus. Okay, so if I get this right, we should be able to put neutral, or ground in our case. Oh, this ground isn't very connected. What's going on with this cable? Yeah, I already suspected we might have to change the resistors in these things, but, you know, it's worth a try. Okay, so let me put ground, which we are shorting with, in the L terminal. And don't put two different 3v3s on that switch. You'll short them both if both are active. Oh yeah, maybe do a multimeter test first. That's like the sane advice. Okay, but how do I do a multimeter test? Because these are capacitive buttons. I don't think this will actually work at all. But we'll see. Okay, multimeter, beeping mode. Yes. No, no. Yeah, so right now there's no connections whatsoever. Okay, no connections whatsoever, right? Okay, so that should be fine. Yeah, there's an N here, but it doesn't go anywhere. There isn't a terminal for it. So, not sure what that's about. I'm no expert at these switches, just so you know, if that wasn't obvious. That's why we're trying things out. You know, it's good to test stuff. And I tested with my people there. That's you guys. Okay, so let's put this in L1. Okay. Okay. Let's try this first. Turn it on. No clue if this is going to work. 24 volt? Yeah, I could, but currently the buttons are 3.3 volts. Probably to avoid having a live dangling. Yeah. Okay, so we're connected again. Let's see if this does anything. Yeah, this probably has a little circuit behind it, which means that it's going to need 230 volts. But then how would it do that without a neutral? It can't do it with just a live, can it? Yeah, that doesn't make sense. Maybe if I pull hard enough. We're into the deconstruction part. Okay. Right. So there's a little PCB in here. And it has some ICs. Oh, okay. Oh, okay. Oh, wow, it has a little connector. Can you see that? Okay, so this comes off. Yeah, but if I look here, there is also only 4 terminals. And then there's... I don't know what these are. Oh, if we could remove the little PCB, I guess. But because it has a PCB, it's unlikely to be working, to get working with the 3.3 volts. But we can see, Oh, probably have to unscrew the cables. Okay. Uh-oh. Okay. Oh, wow. Look at that. Oh, it has a transformer and everything. There's a capacitor here. These are probably some... Oh, my OBS says reconnection successful. Was I off air for a little bit? Hello? Can you guys see me? Oh, I dropped. Oh, wow. Okay. So everything's fine now? Okay. Okay, thanks guys. So, there's lots of stuff here. I think there's some optocouplers and some diodes and some capacitors, and this is a little transformer. And then these might be MOSFETs or some other type of transistor. But yeah, this is clearly constructed for 230 volts or whatever. That's never going to work at 3.3 volts or 24 volts or anything like that. Well, I know from the description this this panel was supposed to have blue and red LEDs if it was on and off. So maybe it's controlling that, and then it has to have the touch input and process it somehow. But this is a lot more elaborate than I was expecting. Nope. Still not. There we go. So yeah, if you look at that PCB, that's a lot of components crammed on there. Yeah, the other side, okay. Oh, you mean this one? Yeah, there's all kinds of transistors there. Okay, let's skip this one. This isn't gonna work. That's pretty obvious by now. So let's get this one back in its housing. So you can't reuse this in your own system, basically, because you can't even get it to switch. Well, that's good to know too. That's why I buy. That's why I buy these things and then tell you what you should buy. Come on, little screw. Never wants to do what you want it to do, right? Yeah, you'd have to make a custom PCB to replace it, but don't feel that's worth it. Then you can probably just as well get it produced completely, you know. Okay, well, it's pretty easy to take apart and put back together. That's not bad. And this probably just snaps back in place. Well, almost. Missed a clip. Okay. Ah, okay, other way around. Yep. Oh, well, it's pretty decent construction. I mean, huh. Okay, so no worky, no worky. That's fine. We have more switches. Okay, so these two won't work. That's fine. Let's see what we have in here. All right, these are interesting too, because it looks blue, but it's magnetic, or it's metallic. Sorry. Ooh, shiny. Let's see here. Well, this is pretty obvious how this is going to work. There is L1 and L2. And, I mean, they're all separately connected, I think. We can do a quick test. And this one, I believe, also should have an LED, but we're gonna see. Let's do the short cable. Wait, is there a third screw terminal? Oh, there is. So this one has L in the middle, and then L2 and L1. Okay. Back to beeping. Right. Okay, let me zoom that out a little bit. Right, so does this do anything? Okay, so L and L1 is connected. That makes sense. But then is L and L... Oh. Oh, so it works in reverse. So now it's on. You can hear the beep, I think. But then this one is off. But if I then flip that switch, now that one is on. Okay. Okay. Sure. So we should screw this one into the middle one. Yeah, single pole, double throw. That's it. Yeah, that's it. And let's put this one in L1. Sorry for my horrible screw work. And let's put this one in L2. That'll work. Okay, let's turn it on. Wait, stop. Logs. Okay, it's booted again, and it's supposed to be this one, so yeah, so this one's interesting. So I connected ground in the middle, and then I have a GPIO on this one and a GPIO on this one, and they're both pulled high. And if I now click this one, it sends off to one of them and on to the other one, but if I... okay, you can only click one way. But now 34 is on and 35 is off, and if I click it, now 35 is on and 34 is off. Yeah, and it changes it around. What scenario would that be good for? Again, sadly, not a momentary press. Nope. This is basically a rocker switch implemented with a momentary switch. Exactly. Yeah, I guess hotel switches. I'll repeat again. I don't have much experience with AC lighting switches. Two-way lights. Yeah, I guess. But you can never turn them both off. Huh. Interesting. Okay. But that's too confusing for now. Right, so let's put this one back into the box. Yeah, there is no both off. It's always one of them on. Okay, let's see what else I have here. No, maybe this one. Or did I already look at that one? Hold on. No, I did already look at that one. So we don't have any momentary switches? Damn it. I was pretty sure one of these was going to be a momentary switch. I guess I'm wrong. Yeah, okay. Well, let's go back to the original switch. It has three modes: off, bright, and less bright. Though only got a normal switch. Yeah, well, if you use two GPIO pins, I guess you could, make... No, you can't control them individually. I don't know what that switch is for. Probably a hotel chain switch, but yeah, I don't use those, so I don't know. Okay, let's open up the original one we were playing with at the beginning. And maybe see if we can make that LED work. Okay. Well, that's pretty easy. Getting deeper than that is going to be a bit more troublesome. Let's try it. I guess I need two screwdrivers, huh? So let's do this and this. Oh, okay. Nope. Oh, there's clips here. I don't mind if I wreck it really, so I'm not being too careful. It's all for science, or the YouTube channel, or whatever you want to call it. Come on, little clip. Let go. Streaming to destruction, what? Stupid clips. There's probably a better way for it that I don't know, but you know. I guess I could do the same over here. Oh. There we go. Oh. Well, great. Well, we got that part removed. More force! Yeah. Okay, so that wasn't it. Although there's slots here. Okay. Yeah. Oh, right, because I pushed these in. Right, okay, okay, oh. The mechanism might have fallen. Holy sh... I am not sure this is going to go back together again. Why? Why did that happen? Oh no. Okay. Yep, found the springs, that's for sure. Okay. Oh man. Right. Yeah, they're not springy anymore, that's for sure. Puzzle time with Quindor. I don't know if I even wanna. But okay, let's continue our research. This little PCB needs to come out now. See if we can do that without destroying it. Okay, so those are the buttons. No, not a 14-hour stream assembling an... Oh, okay. That's pretty easy. Right. Cool. Okay. So, let me zoom that in. The entertainment goes next level. Yeah, right. There we go. So this is, I think, an optocoupler, and then two resistors. Live. Okay. Thanks, Philip. Oh, now my power supply starts making noise. Don't do that. Yeah, okay. Just gonna turn it off real quick. Can somebody look up the optocoupler? It's a... I think it's an MB something. Yeah, so the optocoupler is an MB6S. I guess I can show you guys too, like that. Maybe not. Yeah, so the optocouplers are MB6S. And then it has 2 resistors. Oh, probably bridge rectifiers. Yeah, that's a good one. And it has 2 resistors and 6204. Yeah, they're all 6204. Oh, Andy has a PDF. 1/2 amp bridge rectifier. Okay. So, if a bridge rectifier is in a DC circuit, what would it do? Let's take a quick look at that datasheet. Full bridge rectifier! You get no voltage or full. Yeah, that's right. But no, we already tested it. There was no smoke or fire. Too bad. So sad. Hi, 10dogsvan.com. Not really, unless it's maybe a variation of stuff I'm doing already. But it's best to either reach out through email or Discord and we can talk about that. When will I do a live stream with Electro Boom? Yeah, I think my amount of followers need to 100 times before that. It would supply your LEDs correctly with a voltage drop of 2 diodes. Right, okay. That makes sense. But then what is the drop? Forward voltage per bridge is 1 volt. Right, okay. Let's try something. Because we have... oh. No, let's not do that. Let's do diode testing mode. Right. In theory, we should be able to make this LED burn. Right, okay. There we go. Right, so if I put it on this side, it still works. Interesting. So the multimeter has... What kind of battery does this thing have? Is it 2 AA's or triple A's? How much volt is my multimeter? I don't know. So let's get to let's get my other multimeter. And let's measure the voltage of my multimeters. What? Yes. Okay, so how much volts is coming out of here? Oh, 3.94 volts. Right, so I'm just, yeah. No, well, I think there's maybe 3 in there, but if I measure it with this multimeter, it's 3.94 volts, what it's putting out right now. So if I put 3-point-something volts on this little plate here, so this works. Other way around probably. Right. So that's 3 volts. That's pretty good for the LED. And the bridge rectifier isn't doing too much, because on the other side it's also still 3 volts. Or, well, it's bright. It's less bright. If you see here, it's less bright, but it's still okay. But then there's these. I don't remember. 6204. Can somebody look up a 6204 SMD resistor? Yeah, that's probably way too high. So you'd have to replace these resistors, and would it then work? Maybe, but maybe not. Two times 0.7 volt drop. Yeah, we're talking the bridge rectifier or the resistors. 6.2 mega ohms. What? Well, I guess it could make sense for 230 volt. Okay, let me look it up. Hold on. 6204 SMD resistor. Yep, yeah, okay. 6.2 mega ohms. Wow. Okay, sure. Anyway, right, so, but I'm thinking, because on my controller board, oh, you can't even see that. There we go. On my controller board, we don't really have a positive, because we have a GPIO pin that's pulled high, but that's not really giving a lot of voltage because it's pulled high. It's not actually high. And we're shorting it to ground, and then the ESP detects a change between 3.3 volts on that GPIO pin and ground. But the whole reason we're able to pull it to ground is because the pull up to 3.3 volt is very limited, so ground is always going to overrule that. So without dedicated wires for the LEDs, I don't think that's ever going to work. Yeah, because as soon as it's on, there is no more 3.3 volt because it's switched to ground. Okay. And when it's off, there is 3.3 volts, but it's very tiny, and that's not even enough to have an LED burning. Huh. Wow, there goes that plan. Yeah, because I was thinking, okay, we can replace the resistors, and in theory, we could then drive the LED. But it's not actually a high pin. It's pulled high. So we can switch it to ground. So that's never going to give enough power to have the LED running. Oh. Yeah, I think it's too little because basically the pull high resistor. Oh wait, we should just remove these resistors. And then the pull high resistor will determine the power for the LED. And I believe that's a 1K. No, I don't need a MOSFET. No. I mean, the switch would be reversed, but that's fine. You can do that in software. But basically, your pull-up resistor will determine the amount of milliamps it will go to the switch if you remove these LEDs. Yeah. These resistors. Hold on. Yeah, well, Andy, or Philip. I don't think it's going back together either, or I don't even think I want to try. But it's interesting to think about. I think if you remove these resistors, and then, but then you'd need a really low pool high resistor. That's true, Andy. That's a very good one, Johnny. And guess what? During a recent Quinboxed, I unboxed a lot of LEDs with legs. So we can do that. Let's not do white. Let's do green. Okay. This is off. That's good. I guess I could put it into a Wago. But I think there's a 1K or a 3K pool high resistor on there now. Let's see if I can get this into a Wago. No. That's not going to work. I can screw it in here, that's no problem. If I have my screwdriver. Yeah, well, yo scared. Join the club. We're all doing stuff we only half understand here, so that's fine. And then we need ground. Let's get this out of the way real quick. Don't need that anymore. Ground. Is this connected to ground? Yes, but this is also. Okay, so we have our third pin, which is also pulled high. And in theory, if we turn it on, no, turn the power supply off. Oh, Johnny is here with the SDKS for buying pink LEDs. Sure. We'll work on that. Let's first turn the controller on. So in theory, these are pulled high. So that's providing 3.3 volt. And then this is, oh, hey, what do you know? But then, how do I now test a... Yeah, I need more wires. Okay, right? That's on. But if I now also switch it to ground, it turns off. Oh, yeah, you can't see that. So it's... Okay, hold on. Right, so the LED is on because it's connected to pulled high 3.3 volts and ground. But if we add a ground connection, it'll switch in ESP Home, if we show that. One second. You need a working switch first, yeah. Okay, so now if I connect it to ground, it switches, that's correct. The LED is off, and when I release it, it's on again, and the LED turns on. Huh. Hey, Unexpected Maker is here. We're trying to hack some AC wall switches to varying success. ESP Home says that can work, because we can turn it on and off. That's fine. So that works, and the LED should be blinking. Oh no, wait. Okay, now I disconnected it. It's a very precarious connection here. Yeah, so that works. So we're basically siphoning power to the LED from our pool high circuit. Huh. Okay. Yeah, we can invert it in ESP Home. That's no problem. AC, danger, danger. No, we're abusing it to do DC. But there's a slight problem. Some stuff came apart. So, the switch is in pieces. But I do think we just figured out a way to make it work. And that's just by taking these resistors off and bridging them. But then the question is, can I actually get this to go back together again? I don't know. How does this work? There's all kinds of tiny little springs. And there's lots of pieces. Yeah, that's true. You can make it do either way. Just invert the switch in ESP Home and that'll work. Always buy two. Well, you know me. I probably did. I'm not 100% sure I have two of these, but I have more. I have some of the other switches. Let's see. Can I figure out how this went together? I guess so. Happy to see you live, and you look different today. Well, I went to the hairdresser or the barber, and I got my beard done, and I got my hair done, and maybe that's it. Maybe that's why I look crisper. Come back out. There we go. So, these go in here. Okay. Think. I don't know. And this is a blind. Okay. Is this correct? No. I don't know if we want to watch through it, me stumbling. I don't know about these springs, man. I don't even know what's gonna go where. Let's not. Let's see if we can take another one apart that's easier to put back together. But we kind of already verified the theory, except that it's too hard to break it open and then make it go back together again. This thing is greasy as heck. Though, well, the way it came apart was lots of force, and then it came out as one giant chaotic mess of springs and other stuff. So I'm not sure going back in stream will really work. Yeah, I went to the barber shop and they did good work. I like it. So, in theory, this can work. In theory, if you remove those resistors from that PCB, so if you remove these resistors and bridge them, well, we could do a final test, and the final test would be ground and 3.3 volts on the bridge rectifier. That's not working. Okay. Oh, it's not turned on. Okay. In theory, it shouldn't matter which way... Oh, there we go. In theory, it shouldn't matter which way I connect it, right? Because it's a bridge rectifier. Yeah, I can connect it either way, that's fine. Yeah, so basically, if we remove the resistors... wait. Are the resistors active? No, I don't think they are. Yeah, because they're series resistors. They're not parallel resistors. Yes. So without the bridge rectifier, we get this. And then it is polarized, of course. And then after the bridge rectifier, it's this bright. Which is, of course, less. That's fine. We get that. but the resistors are serialized, so those are currently not in the circuit. So in theory, if we'd hook it up, it would look like this. But then we can never get the switch back together again. So remove the rectifier as well. Yeah, okay. That, yeah, sure. And then it's plenty bright. You don't really want it very bright either. And then you could just use the resistor values on the board to, you know, vary the brightness of the LED. Okay, so in theory it's possible. Let's get this LED out of here. Do we want to try one other switch? Yeah, let's try one other switch and see if we can take that apart. Because this has these very complicated, you know, mechanism with springs and all kinds of other crap. I think I also have some very simple switches. But I don't know where those are. Let me look for those for a minute. Hold on. Where did I put those? Okay. Looking forward to the viral video, how not to modify a switch. Yeah. Yako is also going to the hairdresser tomorrow to look as crisp as Q. Hey. I can show you a full screen crispy. There we go. So this is a very simple switch. It doesn't get. Hey, Dr. Z's is here. We're modifying AC switches to do some testing on them. So this might be an LED. I'm not sure, but this at least doesn't have any complicated springs. I think. I hope. I don't know. Let's do our multimeter test real quick. Let's see here, because this only has L and L1. Okay, now it's connected, and now it's not. Yeah, well, okay, that's pretty easy. And I don't think we can get the, oh, don't do that. I don't think we can get the LED to light up. Other way around. No. Okay, so let's check what's inside of here. And if there's even an LED in here. Yeah, modify an AC switch to do DC. And switch-wise, it works. You can use a switch like this, or, well, a more fancy one we just took apart with clicky switches and stuff like that. That all works fine. But we're trying to modify it to also maybe make the LED work. And circuit-wise, we've just figured out how to do that. But then the switch we took apart, well, I don't think it's going to go back together again. Don't think that's worth anyone's time. So, let me try and... is there screws? There's no screws. Oh, but this is clipped in here. I think. Maybe, maybe not. Oh, okay, well that clip's gone. Okay, we're destroying the clips today. That's fine. Wow, okay, let's get this apart first. There we go. Okay, sure. So this is really simple. Okay. And then this mechanism doesn't look too complicated either. Right. Okay, so there's two little nubbies. But is there an LED? No, there's not. I mean, this isn't an LED. This is just a plastic nubby. What use is that? It's just to indicate position or something? Let me check how this goes together. Oh, it's symmetrical, so it doesn't matter. It's rattling now, but it goes back together at least. Yes, nubby. LED might be underneath. No, I don't think the plastic nubby is an LED. Sorry. Okay, so that sucks because this looked like a nice little switch, but then it doesn't have an LED, so it kind of defeats the purpose. Let me check what else we have. Yeah, it said this side up, right? Okay, so this is 4 switches. Do I also have one with less? No. Let's see what this is. No. Ah, well, we're not going to take apart this one because for the ones who watch Quinbox, they know. But this one is one big button and it does have an LED, but you can just... You can hear the spring in there. That's going to be in the other room if I open that up. I mean, so let's not do that. That's not going to work. We can try one of these. No, this is all. This also has a spring. Damn it. Okay. No, none of these. Nope. Some of these. Tactile button. Oh yeah. Oh, this is one of those. Okay, yeah, we figured out that's not going to work. One of those capacitive ones. Well, then even with my button buying madness, I didn't buy enough buttons because I wanted to have one with a momentary press. None of them have a momentary press. And I wanted to have one where we could hack the LED. Well, the most simple one I have didn't really have an LED. It's just a fake little line there. And then the one that could have worked will never go back together again. Because of very complicated spring actions. Well, that kind of ends the testing, I'd say. So what does this tell us? If you're good at springs and putting them back into switches, you can make this work. If you're not, you can't. Yeah, but those pulse ones don't have an LED, I think. It's teaser time? Oh man, I don't think I have a teaser. Honestly, actually. Yeah, you can power the LED because the current limiting will be in the pull up circuit on the board. And currently that's a 1K or 3K, I don't remember from head. But you could just lower that value to like 500 or even 300 or whatever to make the LED brighter if you wanted to. But then you still have to go into the switch to remove the LED or the resistors on there. Mailback time. No, no, no. Oh, I already recorded a Quinn box. It should be out next week. Yeah, are you good at reassembling this kind of stuff, Emil? So, like these little springs and tension thingies and brackets? In the end, I might not have had to pull that apart, if I'm honest. Because, where did the PCB sit again? Something... Yeah, so the LEDs go here. No, that doesn't make sense. No, the LEDs don't go here, the LEDs go here. Right, okay. So this... was here, I believe. No. This goes here, that's for sure. I think it was like this. And then... oh, there's more springs over here. Let me see if I remember this. Yeah, this goes on the back here. Okay, yeah. And that contacts. Okay, yeah. Okay, well, I'm not going to be putting this back together. Maybe Emil will. Who knows? But I don't think it's worth the effort or time, really. It's a nice switch. It has a nice glass plate and stuff like that, but, you know. Modify the other one, then? Which other one? Oh, you mean one of these? Yeah, okay, look, okay. If we're not done streaming yet, we can take a look at this one. Because this one is basically the same. This one has the push switch, but then... oh, this one... yeah, this one has the middle terminal, and then the left and the right. Okay, bye, Emil. So, let's see if we can get this to go apart. Okay. We have only been streaming 1 hour and 45 minutes, but we'll take a quick look at this one. I'm not sure we're actually going to modify it. Oh, that's true, that's true. Does this come apart? No. It looks like it should be able to come apart like that. And that basically these are clipped in here. But then they're clipped in there very tightly. Yeah, break all the things show. More springs coming. Yeah, that's for sure. I can already see the springs. Okay, I need to bend this piece of metal away. Oh wait, the top is coming off? Do I want that? No, I don't want that. Okay. So if I bend this piece of metal away, in theory, there we go, okay. Right, okay, okay, that's good, that's good. Now we have the switch. That's just in a frame like that. Yeah, sure, we can work with that. Okay, and then there's clips on the sides. But then I can already see the spring over here. So let's be a little bit careful. Okay. That's one side. Ow. Click the other side back together again. Okay. There we go. Okay. Ah, no, click back the other side again, damn it. More screwdrivers in there. Still working. Come on. Come on. There we go. Uh-oh. Uh-oh. Oh, no. Where did it even go? Oh, no. There's the springs. Well, how does it even go together? So this drops in here, I think. Yeah, okay. So that drops in there. But then how do you assemble this? How is this ever assembled? I mean, they must have some kind of jig in the factory that puts this thing in the middle, which I can understand. Okay, right. This thing goes here. That's okay. And then they must have some kind of jig which holds the two springs in the exact right position. Oh, yeah, sure. So, this is the moving part. But then here we have the two springs and the switching mechanism, and I think this goes in here. Oh, no, not like that. This goes in here like that, and then you can move it to rock it around. Okay, sure. But then how do you ever keep these springs? Oh, they go below the piece. Okay. Is it magnetic? And how do you ever do that? I mean, how do you... That's impossible to do for a human, I'd say. Patrick says, I'm never letting Quindor take apart my stuff to see how they work. Yeah, no, I get that. I mean, I bought these to you know, wreck them. No, I don't think they go below it. I think it goes like this, because the pads on here are meant to connect to the pads in there. Sorry about that. There we go. Are they in the black holes? Well, that would make things a bit easier. So we do that. Oh. Maybe you're onto something there, Yako. Okay, so now we have it like that. And in theory, this should then snap back into place. Hey! Let me refocus that. Okay, so this one we can make clicky again. Okay, that's a lot better construction then. We can work with that. If we can get it apart again. Yako gets a beer. Okay. Oh, no. Don't do that. Okay. Right, so we're just gonna... Oh no, there's another spring! But that must have been in here, I think. Okay. So now let's look at the PCB. Or is it in here? No, that never fits. Okay, so that's probably in here. And that's greasy. No LED yet. No, but there might still... Oh, wait. No, how would there be an LED? I thought these also had LEDs. Yeah, there's a hole for an LED there. No, there's an LED. I think it's this little window over here. But let's take that PCB out. Oh, there we go. Here's the LED. And that looks like the same jobby as before. So a bridge rectifier and then two resistors to limit the current. Yes, that's a very correct observation there, Patrick. They're using the springs to get the voltage to the board. Right, so if we test this again, we should be able to get it to light up like this. Yep. And then it should also light up like this, but slightly brighter. Oh, okay. Yeah, we are slightly brighter, sure. So what do you guys say? Should I hot air off these resistors? And then I guess I have to bridge them. Yeah, I'd have to bridge them. Okay, well, we can try that. Let me get out a soldering pad. Let's try and do it with the soldering iron without hot air. Go for it, we have time. Let me turn those on. There we go. Yes, bridge all the things. Oh, oops. Okay. Well, I guess we'll go into ultra zoom mode. There we go. Let's turn this one on. Okay, I'm getting my fume extractor. I know it's probably a bit overkill, but, you know. You guys should still be able to see. Next live stream is not for another 7 minutes. Who's going to stream, Johnny? Okay, soldering iron should be hot now. Need something to hold that down. Okay. Let's try and bridge that. That's one done. And that's the other one done. Ah, okay. CircuitPython deep dive. Nice. I'm gonna leave the bridge rectifier in place so we can test with that. I think that's fun. But that was an easy fix. The extractor is actually a... I don't know if... I think you can get it from Aliexpress. It's an A10... Oh, okay. I'm in zoomed in mode. Sorry. Hold on. It's an A10 ST1016. it's pretty okay. Works nice. It has carbon pads in the back. And a little LED light. And yeah. Okay. So, okay. Well, don't need this anymore. Right. Let's get this out of the way. Did I just hit a live stream? Yes, you did. Okay, where did I put the other parts? Oh, I put them all over here. Okay. So, in theory, this should just slot back into place here. And there's a hole there, so that's where the LED goes. Missed. Yeah, okay. And then, in theory, this and this should go together. Huh. Oh, it's not together yet. Okay. Hey! It's still clicky. Okay, okay, sure. We don't need to put it back in the panel. Because we have this panel it goes into, but that doesn't really do anything. So let's leave it like this. And let's use the long wires just for fun. I'm going to disconnect the small wires, the short wires. Okay. Oh, screw came out. Sorry, I'll zoom out in a minute. Right, so we have our An-Penta prototype board. And I'm going to hook up ground to the middle one again. Because this is one of those weird switches. My sheer competence in what? In soldering or what? I'm only like slightly better in maybe some stuff than you guys. Don't fool yourself. Why not replace it with a WS2812B? Well, then we'd need more wires and more power and different voltages and control currents and... no. Okay, so I put it in L and L1. I don't know. Let's see. Oh, my assembling skills. Well... we wrecked 2 other switches before this one. Okay, let's give it power. Oh! 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 I see it! Do you see it? Oh! It's working! Whoa! That's awesome. Let's go to Chrome. There we go. Yeah, then I guess I have to zoom this one in. Hold on. There. Don't want to focus it. So now there is no LED. And now there is. And it's working. And of course now it does the LED when it's on. And it doesn't do it when it's off, but you can just invert that in software. That's fine. That's, you know. And this switch was actually fairly easy to do. So this was a 2-way one. Okay, that's not going to work again. But I also have a 3-way one. But that basically has the same construction because it just has 3 of those things in the back instead of 2. Right? And although you can use them for a hotel connection if you wanted to, but then again, if you have this button in software, you just do it by software. You only need to hook up one GPIO instead of two, and then it works. Okay, prove it, invert it in software. Sure, sure. So right now, it's on when it's on, and it's off when it's off. Right? On, off, on, off. Okay, sure, sure, sure. Let's see. Edit. I'd need to look up the code to invert it, though. Hold on. I think it's just this. So you add a filter, and that filter says invert. I don't know which pin we were testing, so I'm just going to invert all the pins. So you add a filter, and then the filter is just invert. Okay, let's install that. No, in this way you cannot control the LED independently. It's directly linked to the switch. Well, now. Okay. So currently it's off. I can't see what you guys are seeing. Okay. So currently it's off, and if we switch it, now it says off and the LED is on. And now it's the LED is off and the switch says on. So successfully inverted. And the LED isn't bright, but maybe this would be enough at night. It's not a great LED this way because, as you can see here, there's a pretty large gap between the LED and the window in the button itself. But I guess it works. I mean, if you look at it right, you'll see it. Yeah. So LED on, button off, LED on, or sorry, LED off, button on. Cool. Okay, well that works, and this is just 3.3 volts. And if you wanted the LED brighter, you could just lower the resistor value on the pull-up. So instead of 1K or 3K, I don't remember what we put on there, you could just make it half a K, or 400 ohm or 300 ohm or something like that. You'd have to check if the button still works, so ground needs to be able to overrule that resistor basically, but other than that. And this is even with the 10-meter cable between it. So even if this button is quite a bit far away, that seems to be working fine. Yeah, you could still remove the bridge rectifier, sure. That would also give you a slightly brighter LED. But if you just want to make the minimal amount of modifications, just chop those resistors off of there, and that's it. A reason to keep the bridge rectifier, because now, in theory, I could reverse these wires. No. Would that now also reverse the switch behavior? Maybe. Yeah, you need to replace the LED with a pink one. I get that. I get that. Okay, so now we reverse the wires. Let's turn it on again. Let's see if that is a hardware reverse or inverse instead of a software one. Let's wait for it to boot. Okay. No, it still stayed the same. So even though I reversed the wires in the back, it's still LED on, switch off, and LED off, switch on, like the inverted state we set it to. So that doesn't matter, which makes sense. I think the links are in the description, Jaco. You could check. I put some there because I unboxed all of these in the latest Quinboxed, and I just copied those links, and these should be in there. They're sold with a nice metal. Can I get this off? Come on. The protective film is having a hard time letting go. Anyway, they're sold with a nice aluminium brushed finish. And, yeah, they're pretty clicky, but that's either your preference or not. Yeah. We made a switch. No, we didn't make a switch. We altered the switch for a... No, we didn't alter a switch for a different purpose either. We altered a switch to switch using DC instead of AC, and then still have the LED functionality. That's basically what we did. We only did anything with the LED, really, because the switch was working anyway. Yeah. Okay, so if you want a switch on your QuinLED, you can buy a normal AC switch. Those will likely work fine. And if you then want the LED to work, you just need to remove the resistors inside of the switch. Kind of makes sense. I mean, yeah. And here you can see it switching in ESP Home. Yeah. Nice. Nice. Right. Mission accomplished. No, generally it wouldn't, unless it might not disconnect contacts well enough for 3 volt DC or AC, but then again, it might not work with higher voltages normally. Lower voltages actually need less creepage, so I expected it to work. I just wanted to test it. And well, now we did. So anyone now asking for what kind of wall switch can I use on a QuinLED board? Well, any, as long as it's a switch. And if you want the LED to work, we can fix that too. Nice. Well, currently we used a prototype of a An-Penta, but basically it has a GPIO pin that's pulled high. That's this one. And then it has a ground connection, and you connect that into the switch. And that's it. Cool. Right. So let's do another 10 minutes of talking, and then we're done. We have a successful project in a live stream. After wrecking some other switches, having switches with nubbies inside, and you know, so this one, basically this one will work too. Probably better even with the LEDs and these slots here and stuff like that. But spring-wise, that's going to be a nightmare. But yeah. Cool. Yes, you can do the same with a Dig Uno. But you might need to modify the pull up. So the button pin is pulled up, but I think that uses a 10K. And with a 10K, it'll work regarding switch functionality. That's fine. Switching will work perfectly fine. But if you also want the LED to work like this, you'll have to replace that resistor. But if you don't care about the LED, yeah, sure. And this is using 10 meters of cable, so you can't see the ESP home screen right now, but that's working flawlessly. So that should be no problem. No, I don't think we have any teasers this week. Nope. I can tease you something from the next Quinbox, which I already recorded. Oh, nice! Is it going to be the 12-hour stream, Dr. Z's? No! That's tomorrow? I'm going to be gone from home the whole day tomorrow. The afternoon and the whole evening. Are you kidding me? Is that on a Saturday or a Sunday? Because on a Sunday, where you normally stream, I have time. But not tomorrow. Oh, not 12 in a row. Okay. So I might be able to catch a part of it then. Okay, you'll stream Sunday too. Okay. Yeah, well, tomorrow I just can't make it, but Sunday I will certainly be there. Cool. Oh, well, hey. Switch modification success. Yes. Look at it switch. And the LED is very dim, but it works. Nice. I'm really happy with that. I figured it would work, but, you know, didn't think about those pesky springs. Okay, so you want a teaser from the next Quinbox? We can do that. I still have some stuff here on the desk. I was browsing Aliexpress. What else? What else is new? And I came across these. And these are not in focus. Now they are. And these are T-nut Wago clamps. Or T-junction style. So you can, you know, it's a Wago style clamp. And then you can have, this is AWG 16. Oh, okay. AWG 16 doesn't fit with a ferrule on there. Okay, let's do AWG 18 with a ferrule. So you'd have your plus running, you know, like that. Well, you wouldn't have to connect it like this, because that would already be connected. But basically, you'd have it like this. So plus would run here, and then, yeah, there we go. You can splice it off like that. So basically, you'd have your run go through, and you could also splice it off. And I was like, that can sometimes come in handy for certain projects, like with LEDs, for instance. And yeah, so I thought, okay, that's it. Let's buy all back. But I haven't tested them yet. How many amps they might be able to handle? Oh, it says 32 amps. I don't know about that. And it says it can take up to 2.5 gauge. Where's my magnifier glasses? Yeah, 32 amps up to 2.5 millimeters square. So that's like 12 gauge, but then not with a wire ferrule, because the wire ferrule doesn't fit in the hole. But that's the same with other Wagos too. Yeah, they're not official Wagos, but you mean, it's not like they have bad clamps. That works fine. 32 Chinese amps, okay, but let's say we run 20 through it. And I could maybe make a video testing that, if you guys are interested. But, yeah. So those are in the next Quinn box, a little teaser. Chinese amps, yes. Very different than non-Chinese amps. Right. Well, it's near stopping time anyway. So, yeah, I can do maybe a little short video with my flare to see how many amps it can really handle. We can do that. That's fine. So, but we're going to end this live stream now on a high note because it worked. It can actually work. We can rebuild the switches if we take not too complicated switches. And that is awesome. Well, yeah, relays are something different still. Right, so anyway, I want to thank all of you for being here and some of the really useful tips. Otherwise, we might have stopped before we did this one. So thank you all very much. And I hope to see you guys back in a next video, a live stream, in the YouTube comments, on the Discord, maybe on Twitter even, wherever you can find me. I hope to see you guys there. And catch you guys in the next live stream video, etc. Have a great day. Bye-bye.